So we will be continuing from our next topic, that the rules of naming of a complex. Okay, so the first rule is the first rule is first name the cation, then name the anion. So what I want to tell is that is our famous example K4FeCN46. We will first name this potassium because it is plus charge, and then we will name this coordination sphere because it is in minus charge. In common salts, like NaCl, what do we call it? We call it sodium chloride. Why? Because the sodium is the cation and the chloride is the anion. So in here this rule is also applicable. Okay. Our second point is first write the name of the ligand, then name the central atom. Okay, it is a rule for naming of the coordination sphere. Okay, so we will first write down the name of the ligand, then we will name the central atom. What I want to tell is, suppose CuH2O6 plus 2 is a coordination sphere. We will first name this thing. This H2 we will name first, and this copper we will name second. Okay, first ligand, then central atom. Note down this. I will be rubbing the board. So we will be continuing on next point. Our third point is number of ligands is mentioned. Before the name of ligands. Okay, so suppose, and I am telling the rule first, then I will be explaining this rule by an example. If the number of ligand is 1, then we call it mono. If 2, we call it di. If 3, tri. If 4, then tetra. if 5 then penta, if 6 then hexa, if 7 then hepta, if 8 then octa, and so on. Let me choose the pen color because it is getting faded. Okay, octa. We name this. We number the ligand by this convention. Suppose there is 2H2. Suppose it is Ni H2 whole 6 plus. I will name this ligand by putting, we call it hexa aqua, because hexa means 6 and aqua means water. So number of the ligands is mentioned before the name of the ligand. Okay. And if the ligands are complex in nature, okay, that means they are bidentate ligand or tridentate or tetradentate ligand, then we use another convention. Then we use two, if two ligands are present, and this is for simple ligand, and for complex ligand, two is bis, three is tris, four is tetrakis, five is pentakis. Okay, pentakis. Sorry, in here if one ligands are present, there is no mention of mono in before the ligand. Okay, the numbering starts from 2. I mentioned it wrong. Tetrakis, pentakis, and 6 for hexakis. Let us take an example. If we take Ni whole 3 plus 2. Okay, then I will name this ligand as tris ethylene diamine. Why? Because this tris is used because this En is a complex ligand, because it is a two bidentate ligand, so it is a complex ligand, so this tris is mentioned. And if these simple ligands are mentioned, then only use hexa, hepta, penta, etc. Clear? Note down this. I will be writing the board after this. So we have completed the third one. The fourth rule is ligands are named in alphabetical order. Okay, so what do you mean by this? Suppose we have a complex NiH2O Cl Br F. Okay, and here -1 charge is there. Okay, so we will name this ligand, we will name this is aqua, this is chlorido, this is bromido, this is fluorido. So first we will take aqua because aqua starts with A. Aqua chlorido, no aqua, no chlorido, then B, alphabetical B, bromido, chlorido, then C, then fluorido. Okay, so you can see here we are naming in an alphabetical order. And another aspect, important aspect of this ligand point of view, that is number of ions or ligands are not mentioned. Okay, number of ions or ligands are not mentioned, are not considered in the alphabetical preference. What I want to see is, suppose I will take an example. That is, okay, let's take these examples. Ni okay, NiH2O Cl F2. This is aqua, then this is chlorido, and this is fluorido. While we name this, listen, first we will write here aqua because AQ comes first, then it is not fluoride. Here two fluoride ions are there, so it is bifluorido. But this bi thing, Bi, this Bi is not considered in the alphabetical order. This F is considered in the alphabetical order. So this chloro comes after A, so chlorido, then comes bifluorido. Okay, so this Bi is not considered in the naming of the ligands. Okay, this is the point here. Note down this, and after this I will be explaining the next part. Okay, so as a last point. The naming of this thing. The last and fifth point is oxidation state of the central atom is mentioned in bracket after the name of the central atom. What I want to say, suppose we have NiCl6 minus 3. Here oxidation state of nickel is +3, because +3 minus 6 is equal to -3. The charge is back balanced. So here I will write this is minus charge on the, so this is nickelate, NiCk nickelate third. This nickelate, remember nickelate, minus charge in the coordination sphere, then 8 ends with 8, nickel nickelate. If plus and 0, then no modification. Remember, nickelate third. What I want to say, that the third oxidation state is mentioned after the name of the nickel, this nickelate thing. Okay, this is the rule, and note down this. I will be continuing the examples after this. Okay. So let's continue the examples. First, our famous example comes. K4 FeCN6. Then suppose we choose K3 CO C24 whole 3. Then we will choose CO H2O whole 2 En2 Cl3. Then NiDMG whole 2 and then CO NH3 5Cl after Cl2. Then PT NH3 whole 2 Cl NH2 CH3. Outside Cl. first try this, then I will try to explain this. Okay, hope you tried. Now I'm explaining this. Okay, so the first rule what we have learned, that is this potassium is plus charged and this coordination sphere is negatively charged. First we have to name the positive charge. Okay, then what we will write? Potassium, let me take another potassium, then we will name the anion, and that is coordination sphere. In first, what we will name the ligands first. Remember, I have taught you ligands first. Then it is hexa, cyanido. Why cyanido? Because it is an anionic ligand. Cyanido. Okay, cyanido, hexa cyanido. Then the central atom, ferrate. Then the oxidation number. Okay, oxidation number is that X minus 6 plus 4 is equal to 0, then X is equal to 2. Oxidation number is 2 plus 2, oxidation state, ferrate 2. Okay, we have named the first. If you didn't understand, then rewind the video and again watch it. Then we will name the second. Okay, this is potassium because it is cation, so name first potassium. Then the coordination sphere, which is negatively charged or anion. This is a complex ligand, so we will not use tri word. We will use tris word. We will use tris. Oxalato, as the coordination sphere is negatively charged, so we will have to turn this cobalt into cobaltate. Okay, cobaltate because negatively charged, so central atom cobalt to cobaltate. Then the oxidation number of the central atom. What is the oxidation number? Look, this is minus 3 into 2 is minus 6, and it's plus 3 minus 3, so plus 3 is the oxidation number. Calculate yourself. Cobaltate 3. Okay, then it is, what is this? Okay, so it is chloride ion. This is minus charge and the coordination sphere is positive. So here we will have to first name the positive charge. So we will first name the coordination sphere. So bi-aqua. No, bi no. This is di-aqua. Sorry, what I'm right. Di-aqua bis ethylene diamine. This ethylene diamine, positive charge, no modification in the name of central atom, cobalt. The oxidation number of central atom is what? This is plus 3. Okay, plus 3. This is because this is minus 3, this is plus 3, so this is neutral. Cobalt, then the anion, chloride. chloride. The interesting thing or what I told is chloride, the number of anions are not mentioned. This 3 is not mentioned. We have to calculate ourselves how many chlorides are there by using this oxidation state. Okay, only write chloride, and in case of ligands write the number. Okay, so the next is NiDMG. It is dimethyl glyoxymeter. Okay, so this is a complex ligand. So this dimethyl glyoxymeter, why I am writing oxymeter, because it is an anionic ligand and the coordination pair is no charge, so no modification in the name of the nickel, NiCKLe, nickel 2, because this is -1 charged, so this has to +2 charge, because -1 into 2 +2. Okay, I wrote it right. Let me check. Okay, so the third thing we study here, the example we name here is, okay, this is positive, this is negative. Then chlorido, no first chlorido, this is amine, this is chloride, A becomes before C, so penta amino chlorido. Remember what I told, this penta, P word does not count in the succession of the alphabet, so here A comes before C, that is enough. We don't count this penta in the alphabetical rule. Okay, penta amino chlorido, positive charge coordination pair, no modification in cobalt. How many of what is the oxidation state here? Cobalt +3. Okay, cobalt +3, chloride, cobalt +3. Let me check. Pentamine chloride, cobalt chloride. Okay, I have to write it right. Okay, then oh my god, this is negative and this is positive, so first we have to write the positive. So this is diamine chlorido methyl chloride, both are different. Methyl chloride, platinum, methyl chloride, platinum. What is the oxidation state? Chlorine 2, chloride. This chloride is for the outer sphere anion. Okay, and this chloride methyl chlorido, no, this is not chloride, this is chlorido. This chlorido is the ligand. We will be continuing example in the next lecture. Thank you.